Hello and welcome to our fourth meeting of CKAD group. I hope you are fine. I'm quite rested after my holidays last week, and it's really good to be here back with you and to cover the next topic, which for today will be application development. But before we move on, just a couple of things. For the people who are here for the first time, my name is Łukasz Tomaszkiewicz, but you can call me Luke Tomas. It's easier to call in English. I help developers and DevOps engineers to accelerate their career in the cloud. You may ask how I do it. In a couple of ways. For example, I run YouTube channels, both in Polish called Kursy Cloud/YouTube, as well as Luktom Cloud/YouTube on which you are watching me right now. If you like the transmission, if you like the study group, please subscribe to the channel and also give a thumbs up because it's important for YouTube algorithm. I also create online courses. I created two of them so far. First one is about Terraform, which is the leading provisioning tool for the infrastructure, and second is about learning developers on how to develop on AWS Cloud. I've also recorded recently a short course on infrastructure as a code. It will be available soon on Luktom Cloud. That will be the first course in the English I recorded. I also run on-site workshop, so if your company wants to have some kind of workshop related to the infrastructure topics, I can run that for you on-site or maybe in a hybrid manner. I ran two software houses in the past. We created .NET software, so I'm quite experienced with both development part as well as the operation side, so I think I can understand what troubles developers have and what are their mindset. I also work as senior cloud infrastructure architect at AWS. It's almost 2 years there, and I think that's all. We can go to calendar and agenda for our meetings. So basically, as you already know, all our meetings are happening every Thursday at 5 p.m. UTC time. So far, we've got a couple of them. We've got 3 meetings. This is the 4th meeting. And today we will cover applications deployment. Next week, we will cover application observability and maintenance. And then we will cover things like environment, configuration, security, and then our last meeting will be devoted to services and networking. I hope you have already booked your day of the exam. I strongly suggest you to do so because it additionally motivates you to take care about the learning and put it in your calendar. So today we will cover application deployment, which is quite nice topic because this is very useful topic. I can discuss different topics related to Kubernetes, but this is really useful in practice. What's inside this exam domain? So basically we've got 3 topics we are going to cover today. So first we will understand what are deployments and how to perform rolling updates. If you were with me since the first meeting, you probably already know what the deployment is, but I will quickly recap what it is if you are here for the first time. Then we will go to the more advanced strategies of deployment and how to use that Kubernetes primitives to introduce the strategy of canary deployment as well as blue-green deployment. And finally, we will get familiar with Helm, which is a package manager for Kubernetes, the most popular one, and also very useful tool when it comes not only to deploying the ready-made packages, but also creating your own. And by the way, creating your own packages is not in the scope of the exam. The exam covers only the part related to deploying existing packages, so you don't have to worry about creating them. So going forward, first we've got deployments, and as you already know, quick recap from the previous meeting, deployments are the most popular type of controller. This is something that runs on controller manager in the Kubernetes controller plane. and they coordinate deployment of new versions of pods. So basically, if you want to deploy any kind of new version of software, or maybe you want to change the configuration of your software, like, I don't know, environment variables, deployment is a good way to go with that approach. Deployments under the cover use something that is called replica set. We will get familiar with that today, and I will show you in practice how it works. And the important part about deployments is that they prevent downtime of workloads. I mean, default configuration of deployments guarantees you that basically your application will be up all the time and there will be no downtime at all. Then we've got rollback functionality. If something wrong is happening to your application, or maybe you decide that this version is not working correctly, you can always roll back deployment to the previous version, and Kubernetes will take care about that. One remark here, basically this is on the infrastructure side. However, your application needs to support that. And what I mean by support, for example, if your application is tied to a database or maybe other storage or maybe some external sources that depends on that, you need to implement the logic for backward compatibility within the application, as well as being able to work with rollback. The best example, for example, if your application is dropping some kind of column from the database because it's no longer needed, and you need to take care in your application that that column can still exist, or maybe it doesn't exist in the new version, but your application needs to handle that difference, because it's possible that during the deployment both versions of applications are working simultaneously, and basically in some rare cases, or not rare cases, your application may crash as it does not expect that database is in such format, for example. So be aware about that. This is something outside of the exam scope, and I won't cover that in detail today. However, keep in mind that your application needs to support things like rollbacks. And then deployments are the basic way to scale your application. So using deployments, you can set the number of replicas manually, or you can use something that is called horizontal pod autoscaler, which scales application automatically for you. Okay, then we have something that is called health checks. This is the mechanism I will cover in details later today, and you will see the sample health check. Why it's important in terms of deployment to have health checks? Because this is the only way to tell Kubernetes that your application is actually working. So it's important also because Kubernetes makes some decisions around about continuing the rollback or continuing rolling out of the pods, depending on the health checks from your application. And there are a couple of good practices around that health checks. I mean, they should quite quickly respond to the requests that are coming from Kubernetes, and also be aware that if you are, for example, in health checking the parts or other parts of the system, it may result in the cascading failure. I worked with one application when we need to change the health checks. Because the health check checked things like console, like a vault, like database, and in case, for example, if database was unavailable, a health check raised that it's also red, so it's not working. And when Kubernetes found that the application is not working, it restarted it and take actions to recover the application, which was completely unnecessary because application was fine. However, the dependency of the application in terms of database was not running correctly. So basically, my advice here is not to include the dependent parts of the system within your health checks. As you remember, a deployment is quite easy thing. You just need to declare things like kind deployment and of course API version. Then you've got metadata, which are typical, which is typical for Kubernetes, and then you've got a deployment specification inside that manifest. What is important, just to recap, it's number of replicas. If you put some number here, Kubernetes will automatically scale to match that amount of pods. The very important thing is also a selector. a selector needs to match the selector that you are providing in the template, because this is the way Kubernetes recognizes which pods are from this specific Kubernetes. There's also some parent-child relationship, but this is used for other things and not directly to cover a number of replicas. By the way, okay, let's go further. Then we've got a typical specification for the pod, which contains, for example, containers in my case, and this is Nginx here as a sample of the container. Just to remind you, there are a couple of basic operations you can perform on the deployment. Of course, you can change things like version or number of replicas inside your code and then deploy that code. However, you can also do it imperatively, sorry. And by imperatively, I mean this is, for example, invoked from the CI/CD pipeline. There are cases in which you need to, for example, wait for the deployment to complete, or maybe scale that from the external tool. And these commands can be helpful for you. You can invoke them and just update the deployment. The first one is updating a specific container. In our case, it's a container image for Nginx, and we are setting that to the newer version. Then we've got the status, which shows us how deployment is progressing. Then we've got a history of deployments where we can see what were the versions in the past. And then we've got also a rollout undo command, which by default goes back in time and restores the previous configuration of the deployment. Of course, by providing additional arguments, you can set the undo to go back to any other version. Let's go further to the next slide. Yeah, this is about scaling. By using kubectl scale, you can scale your deployments by providing a number of replicas from your command line. So also quite helpful if you need to script something. Okay. So first thing I want to talk about and also want to show you in a minute is a rolling update. A rolling update is a way to incrementally replace resources with newer versions. And basically I prepared today my old surface just to be able to draw that for you. I thought it will be funny to have that ability to draw and sketch on the screen. Just let me quickly wake it up. And okay, and here we go. So basically, if we are doing a rolling update, let me do some cleaning on the desk. We've got a couple of pods. For example, this is a version 1 of pod. All of the pods are in version 1, of course. And during the rolling update deployment, what does Kubernetes do? So basically, it does a couple of things. So it adds a new version of pods. For example, here it puts v2 and adds it to a pool of pods that are running on the Kubernetes cluster. So basically, new version is deployed, and then Kubernetes does a health check here. This is a health check, HC. And Kubernetes probes that new version of application if it returns a correct result from the health check. So if that specific pod is returning a status of healthy, Kubernetes progresses with rolling update and then removes one pod with the other version. Then it deploys another one. So for example, we've got then another one, v2 version. And Kubernetes does the same thing, I mean performs health check and waits for that pod to initialize. And after health check is completed and green, then Kubernetes removes another node. So as you can see, at any point of time, we've got a working application, we've got two versions running simultaneously, and Kubernetes ensures that there are at least some of the pods from at least one of the pod from the previous version, just to ensure that application is available constantly. So this is how it works. We've got some questions. I will answer that in a minute. Now let's consider what happens if we have some kind of situation where new version of application is not working. So we've got again v1 and v1, and then we are deploying a new version, v2, and then there is a health check for that specific version, and let's assume that that health check fails. So in this specific scenario, what happens? Actually, Kubernetes is not progressing with the deployment, so it's not deleting the first pod. Let me maybe point it here. So it's not deleting that first pod. It's just waiting for a new version to complete, and in case you've got some monitoring in the cluster, and then you can detect that there is some deployment that actually stuck, and we need to take some kind of action to restore that cluster. So basically what you have here is just a running application. The application still has 3 pods that were deployed previously, and it can use it just to deploy, just to ensure that application is available. Okay. Now let me quickly focus on the questions. What do you think to prepare a GitHub repository for training? The goal is to have exercises to check knowledge and improve for exam. Yeah, sure. It's a good idea. I will think about it. Do you make available somewhere a repository with examples? Yes, I will create that repository. If you want to get it sooner, then just write me a mail and I will send that to you. Just zip it and put it somewhere. What kind of options should we know for exam and which are useful for real life? Okay, so I will talk about that in a minute. Quickly, let's go back to my presentation. So now we know what exactly is happening and how it looks like to do a rolling update. As I mentioned, it checks the health, ensures app is available, default wave of updating deployments. Yeah, this is important. If you do not specify any other strategy, rolling update is a default behavior for Kubernetes. And what is the other possible strategy? It's called recreate. So basically Kubernetes deletes all pods and then creates again with the new version. But that strategy does not ensure that the application is available whole time. However, that recreate strategy is mostly used for stateful sets, because in stateful sets it sometimes can be hard to do a rolling deployments due to the nature of stateful set. So basically, I often use recreate both from daemon sets as well as for stateful sets. What is important also in comparison to other things that I will talk about today is that this is built in within the deployment object. So basically you don't have to install anything new, you don't have to do any kind of custom coordination around the deployment, and that rolling update behavior is actually built into Kubernetes. And as I mentioned before, your application needs to support that kind of deployment, because if, for example, new version is running and migrating the database, older version of database can fail because of the changes in the database. And there are also 2 additional fine-tuned parameters, I can say, which may be important during the exam. And there is a parameter called max search and max unavailable. So basically, max search is telling us how many new pods Kubernetes can add to the cluster. In the case I presented to you and draw on my whiteboard, this is max search was set to 1. So Kubernetes basically created new pod, the one pod for new version. But you can, for example, set max search, for example, to 3 pods, and this way Kubernetes will start by creating 3 pods and then doing the health check of 3 pods simultaneously. So this is the one thing. And then there is also max unavailable. It tells us how many nodes Kubernetes can take from the previous version before confirming that the new version is running already and returning the health check. Why do we need that parameters? For example, you can use max search if you want to have deployments that are faster. if, for example, your application takes a long time to initialize and return the health check for the first time, it may be a good idea to increase max search, and this way Kubernetes will deploy multiple simultaneous containers of the new version. However, of course, that approach requires additional capacity on your cluster, because each and every pod requires additional CPU, additional memory, and possibly other sources. So you need to be prepared that it will take additional resources in your cluster. And then we've got max unavailable. Max unavailable is a nice parameter if you want to keep your resources and be able to do a deployment in case you don't have additional capacity. For example, if you've got very small clusters like on the edge or just small on the resources, you can set max unavailable to bigger number. So this way Kubernetes will just remove the old version of applications to make space for the new version of them. So that's how it works. Okay, we've got 2 questions. Can we choose the version for rolling update, not last but any previous one? Yeah, I will show that to you in a minute. And actually, not in a minute, but now. Let me quickly change the screen. Today I will make sure that you are seeing what I'm doing here. Just a couple of words as an introduction. What we are seeing right now is a tool called K9S. It's quite hard to say, but it's K9S. And this tool is actually a very, very nice interface for Kubernetes clusters that works directly from the console. So you don't have to, deploy any kind of kubeless or similar tools and then set them up. You can just, go to the console, make sure that you've got some kind of kubeconfig context set, and then just call K9S, and it automatically connects to the cluster and allows you to quickly navigate through the cluster. For example, I can go, I don't know, to ingresses, or maybe to services, or maybe I can go to deployments. We will be talking about that later. So you are seeing a basic cluster. This cluster is a one node cluster that I run using K3S. K3S is a very small Kubernetes deployment that takes just one process to run. I highly recommend that deployment, K3S. It's quite useful and quick to deploy. Okay, maybe I will put in the chat both names, K9S. So K9S is a text user interface tool for management, and K3S is one process cluster. There's also, by the way, something that is called K3OS. This is operating system for Kubernetes. Or K3S. And by the way, I worked on some project that we deployed K3OS on Raspberry Pi on the edge, so it was quite nice, quite funny, and I highly recommend K3OS if you just need a very small system just for practicing and training Kubernetes. So that's the other story. And what else I prepared today? Let me open another terminal. I prepared a couple of examples. For blue-green deployment from Helm, and I missed Canary, but we will do that interactively, I can say. Let's go to the rolling update and see what we have here. As you can see, we've got a couple of Kubernetes objects. First object is a deployment. You can see this is the sample deployment. It deploys 2 replicas. It deploys 1 container. This is a special container I wrote 6 years ago. It's quite useful for testing what happens if the application fails. You can invoke that application and just make it fail, or make it answering to health checks in the negative manner, I mean unhealthy. And it can also fail at a random time So it's quite useful if you are learning and just want to see what happens. There are a couple of things like environment variable. Here, this is the app name. We will be actually playing with that parameter. I'm not going to update the image of the class of that application. I will be just changing the environment variables to simulate the deployment of new version. And as you will see in the minute, we will check that using the browser. What else do we have here? We've got a service. This is just a sample service that maps our pods. And then we've got an ingress here. Ingress is here just to do one simple thing. Basically, we will be testing that from the browser, and as you can see, and nothing is running on the cluster right now. There is no ingress for that. So let's go and deploy first version of our application. Let's go to kube control, apply, -F for file, and then deployment. This is a basic command. That command takes the file deployment YAML and sends it to the cluster. So as you can see, if I click enter, then the deployment is created, service is created, and ingress is also created. And now let's go to my cluster. And let's see what happens. And nothing happens because I deployed that to different clusters, sorry. Let's delete that. I need to select my cluster, sorry. I've got that quick alias for selecting the kube control context, and now it's working just fine. I'm applying my deployment, and now we can see that the containers are creating on my cluster. So let's quickly see what was created. First, let's examine deployment. How to navigate K9S? Basically, I'm doing a colon, and then I type deploy, and then press enter, and K9S is automatically switching to the view of the deployments. And there are a couple of interesting things here. You see there is our deployment over there, running update. You see how many pods are ready, how many are up to date, and up to date means pods are in the newest version. And also available here tells us how many pods are responding to the health checks and are healthy. We can go with arrows up and down, or J and K similar to Vim through that console, and then we can press D in order to be able to see the description of that object. So basically, it shows us not only the YAML file formatted in the nice way, but also provides some additional things, additional information, for example, about the replicas. This is very useful line, and especially if it's that nicely formatted. You see that we want to have 2 replicas, 2 desired says that. Then we have 2 updated. It means that there are 2 replicas in the newest version. 2 in total, which is the number of all pods of all versions. And then we've got number of available pods. This is the pods that are healthy. And then the number of unavailable pods. These are the ones that are not available, not healthy. You see that we've got settings here also for that rolling update strategy. As you can see, we've got 25% by default for max search as well as max unavailable. Depending on number of replicas, you can lower or make it bigger for that max search to match your capacity of the cluster. What else you are seeing here? There is a section called conditions. This is especially useful if you are using some kind of scripting, because you can read that conditions, and these conditions tell you if the deployment already concluded and completed. And there are also events. As you can see all the things that are happening inside the cluster, and all the things are here. Okay, I'm just pressing escape, and I will show you another thing. I mean, we can press Y to see the YAML definition of that file. This is unformat YAML file that is strictly coming directly from Kubernetes API. So this is quite useful. As you can see, this is similar to what we saw in the previous view. However, this is just a pure YAML thing. What else may interest you? If we press S, K9S allows you to quickly scale your deployment. So basically we can, for example, go for 5 replicas. And as you can see, Kubernetes is scaling that. There are a number of ready nodes here, and they are waiting for being deployed. Why it takes so long? It's simple, because I wanted to do so, and I implemented a quick hack here. I created something called Startup Probe. And basically Startup Probe is run just after container is deployed, and it checks once for if the container is healthy. So actually using Startup Probe, we are not monitoring our pod the whole time. We are only waiting for pod to start and tell Kubernetes once it's ready. It's just for simplicity. In production environment, you want to implement both startup node as well as readiness probe as well as liveness probes, which I covered in one of the previous meeting, and we also covered that in depth on the next week on our next meeting, where we cover application observability and monitoring and all our other stuff. What solution? I've got a question here on the chat. What solution do you propose for updating database schema? How to use Flyway or Liquid Base with app updates on Kubernetes with new app version? Very good question. It's so important question that I need to change and draw something. Let's go back here. One moment. I need to change the look, and let me move that thing up. Roll it to the bottom. Okay, so the thing is that if you've got, for example, V1 and you've got V2, and you want to do some kind of update here from V1 to V2, and there are a couple of important things. One of them is actually updating of the schema of the database. And what I suggest is to actually do a job here. This is the one option. So we are not only, maybe not here. Maybe let's write it over there. So we've got some kind of job here deployed along with the V2. So basically, if our CI/CD pipeline is sending a new version, then we are deploying not only the deployment changes, but also deploying some kind of job that does a migration for you. And this is tricky. To actually coordinate both of these things. And you can, for example, use that startup probe in your application to check if the schema is in the proper version, and then your application is basically waiting. But this is also not so good kind of deployment. I will go back in a minute for that. But why I want you to separate these two things? Why not run database migrations, for example, here inside the application? So main reason is if you are deploying multiple versions of or multiple pods of new version, let's say 3 new pods are deployed with V2, then we've got a problem. We've got a problem of the kind that all 3 containers will start migration of the database. So we've got a race condition. All of them are, trying to migrate database. Probably also add some fixtures, which are, preset kind of data. And it may be, some kind of issue here or duplicated records or just it may fail. So I highly do not recommend doing migrations inside the application. what I suggest is doing that as then some kind of one-off job. Also, the approach with the separate jobs gives us the following ability. We can set that our job runs with the greater permissions. So for example, our pods has only permissions to select, insert, update, or delete. However, our job can have administrative privileges to the database, so it can alter the schema. So by just doing that one thing, your application is more secure, because even if someone injects drop database students, then nothing's happened because your application does not have permissions to do so. So that's it. What I did in the past to actually accomplish that thing, I use Argo CD, which I will cover somewhere in the future. Argo CD has something that is called pre-deployment hooks, and it can actually coordinate deployment, for example, of that job, and then it can wait for the job to complete. And after that, Argo proceeds with deployment of the new application version of application. So you don't need to take care of that manually. So that's how I do it. Okay, next question from Arthur. Do you share somewhere app code you use during presentations? I can share it, I think. Yeah, I'll just write email. I usually forget, to publish that, and I also don't want to publicly show everything. If you want to get any kind of presentation or any kind of code, just write to me after the presentation, and I will send that specific part to you. So it's usually quicker. How to use job as database migration. So we use job as a database migration, but how to trigger this job and when should it be run? Scale to 0 app, run job and deploy new version. What about blue-green? Yeah, so basically I think I answered that using the Argo CD. Argo CD does have that specific things related to the hooks, and it also implements something called waves. So basically, if you have multiple objects inside your repository, inside your manifest, you can annotate them with a special annotation with the wave that it should be deployed to. And what Argo basically does is, for example, let me go here. So for example, we can mark that that object with the job as a wave 1. So Argo deploys that and waits for it to complete. And then we can mark, for example, that thing as a wave 2. So basically it goes after that. And of course, we can do some additional things, like if you need some kind of cleaning, you can then run some other objects with a wave 3. Oh, that's kind of fancy way to draw that. But it's okay. Okay, so this is how it looks like. I showed you how it works in theory, but let's do it in the practical way. Let's go to pod, the view of the pods. Then let's also go to namespace default to filter out only that things. And of course, I need to change the screen. Yeah, I remember. Okay, so I switched here by pressing just number 1 on the screen to change to the default namespace. And now I will open another terminal here. So you will see both of the things. And I will change that part here. Oh, but maybe before we go there, let's refresh our page. As you can see, our web page is telling this is root of rolling update v1. And I want to change application name to rolling update v2. So I'm editing a thing here. And you can see side by side how it's running. Let's now apply that job again. So again, I'm calling kube control apply f deployment. And just watch what's happening here. So my deployment was updated, and as you can see, due to the restrictions on the max search and max unavailable, Kubernetes is actually starting with one new pod, sorry. with new version, and then tries to terminate 3 of the previous versions. So it actually matches the default setting of max search and max unavailable. And then you will see that after that pod is running and returns a health check, which should take around 20 seconds, it progresses and tries to deploy another pod. So let's wait 20 seconds. After 20 seconds, our probe should be healthy. And now we are waiting also for Kubernetes to terminate that node. And in a minute, in a couple of seconds, we should see another pod starting here. Let's wait. Next question from Arthur. What about with migration that can't be run while application is running? This is called non-cloud native migrations, and we highly discourage from doing so. Yeah, you can see that. Oh, I did one bad thing here. I didn't mention. I mean, if you've got migrations like that, there is no way you need to do some kind of downtime or go with blue-green deployment, which I will cover in a minute, but with database as well. What happened here and why this is there are only 2 replicas? This is simple. Let's go back to our deployment. Deployment. And let's see number of replicas here. As you can see, I've got 2 replicas, so this is a problem if you want to somehow scale your Kubernetes deployments. If you specify that number in manifest, it means that Kubernetes will override it every now and then where you apply the manifest to the cluster. So basically, you saw the behavior of terminating more nodes than expected due to that specific thing. I will remove that, or maybe do it another way. Let's do 10 replicas, apply them to the cluster. You should see 9 new containers starting, and this is the thing, and they are running. And let's deploy another version. You should see v3 here. But before we do so, let's confirm that actual version 2 is running here on the cluster. So as you can see, we already updated that to v2, and now we are going to v3. Okay, so we've got 10 replicas, now v3, and let's wait a couple of seconds so everything is blue. And that means it's running and healthy and all of things are good. And now let's apply v3 and see what happens on the cluster. So as you can see, there are a couple of new nodes that were deployed to the cluster. You see 5 new pods that were deployed, and now Kubernetes is terminating 2 nodes. So you see that in that specific moment we've got 15 nodes that are here running from that application. By the way, we can go with kube control rollout status deployment, and what was the name of the deployment? Rolling update sample. See what exactly is happening using that command. So as you can see, that specific command tells us what is happening right now. You see that 3 replicas are pending termination, now 2 replicas pending termination, 1 replica, and you see that 9 of 10 and then 10 of 10 are deployed successfully. So basically you can see kind of informations like that. Just to show you the whole story here, let's do a v4 migration again and quickly run our rollout status. So you can see with your own eyes how it's working. Side by side what is happening inside the cluster, as well as what exactly Kubernetes does here. Okay, we've got what extension do I use with Vim on the Windows? What do you do to have completion with terminal? Okay, so first thing, I don't have any extensions for on Windows. I simply have Ubuntu here. This is Windows subsystem for Linux. Ubuntu does not have release, but basically this is Ubuntu. You can see and that it's using Ubuntu. So this is Windows subsystem for Linux. This is very useful thing. Basically, you've got full Linux virtual machine that you can use. I use it for all things like development as well as management of the infrastructure. It integrates very nice. For example, it has also capabilities to run graphical applications. So for example, I run IntelliJ from within that WSL. So it's working quite nice. And I've got Vim here. This is one thing. And second thing I'm using is Fish Shell, and this is Fish Shell. Fish Shell has nice things like completion and other stuff. I mean, out of the box, I can say, to be honest, because I haven't configured anything with that Fish Shell to have that kind of syntax highlighting and auto completion. Okay, as you can see, it finished here. Now let's quickly examine what we can do with our history of rollout. Basically, just check the history of our deployment. And as you can see, we've got 4 revisions. Just to show you, we are currently in the V4, but let's say I don't like V4. V4 has some issues. I want to roll back my application to the previous one, which was stable, and then I can just do kube control, rollout, undo. And what Kubernetes does is actually it does the opposite thing. I mean, it returns to the previous configuration of my deployment. So as you can see, it's starting new nodes, but with older version. So if we were to refresh that a couple of times, we should see that some of them are responding with V4, and within a minute after they confirm that V3 is running correctly and health checks are passed, I will see that some of them request return V3. As you can see, we've got 2 versions running simultaneously. And within a minute or 2 after it stabilizes and deployment is completed, we should see only V3 in our cluster. So it's looking like that. As I said, there is a switch over there that we can actually show the revision that we want to go back to. So you can specify it here, but to be honest, I have never used that because I'm for all my clusters or all Kubernetes clusters, I use something called GitOps. You can just type my name and GitOps in Google. There is some kind of presentations in Polish around GitOps approach, both on Kubernetes as well as other tools. So this is it. I basically covered running updates and couple of additional things. Now because time is running, let's go back to our presentation and let's quickly go through what we have here. We have a presentation with the next topic, which is blue-green deployment, if I remember. Why it's not working? Yeah. Okay, because blue and green deployments and canary are actually another subject for the exam. So actually we are here in the second topic for today, using Kubernetes primitives to implement common deployment strategies. Why it's formulated like that? Because here you will see how you can use the basic things like deployment, like service, to build something that is more sophisticated. In our case, that will be a blue-green deployment. So what is blue-green strategy? So basically, it's all about maintaining two versions of our configurations and running two versions of the infrastructure. Of course, you don't have to run that all the time. You need to only run that during the deployment. And we basically deploy the new version, test it, and then we do a switch. Let's quickly visualize that. Let me write something on my whiteboard. Here's the whiteboard. Switch the screen. Okay. Let's maybe the color as well. I don't know how to do it, but there should be some way in that nice tool. Select again for more options. Okay, so let's assume we've got some kind of blue pods that have a V1 here. We've got 3 pods of V1. And now we want to use can we add some descriptions to revisions? Yes, there is a switch for that. I don't remember, to be honest, which one is, what kind of switch was that, because I have never used it in practice. Back to our topic. So we've got our VMs. We've got 3 VMs that we call blue, which represent the previous version. And then what is important here, we've got also service. Service plays a major role here. And not as a theme, as VC. And you know, when we start our deployment, service points to these 3 pods. So basically it works like that the traffic is coming here to the service, and then service distributes that to the V1 pods. And now we want to do a blue-green deployment. So basically we need to deploy a new version of pods. So we are deploying a new version of pods. We can deploy them all simultaneously. And what is important here is that these pods has different labels. So basically they are not automatically connected to that service. By just simply deploying them doesn't mean that traffic is flowing to these pods. So why is that? It's because we don't want to do it, because we want to test that new version before we switch the traffic to that version. So basically we deploy V2 pods, then do some kind of testing, maybe integration, maybe performance testing. And after we decide that new version is running smoothly, running correctly, we then tell our service to point to these pods right now, and then we delete links like that, these pointers here. So basically we can, you know, just remove that lines, and our service is now pointing only to the V2. Why do we want to do in that way? It's especially useful if your application does not support things like rolling update and can, you know, crash during this kind of deployments. It's also a little safer because you are not messing, you know, between 2 versions and mixing the 2 versions of applications running simultaneously. And also maybe not in Kubernetes, but in other cases, it's also a practice that we use with immutable infrastructure, and by using that we just basically following blue-green deployment. Okay, so this is it regarding the theory. Let's go to our local screen and then to another example. Okay. So I've got a second example for you for today. First, let's remove everything we created here. We can run kube and control delete .f deployment. This way we delete all the things that are specified in the file. Just a quick remark here, because it reads the whole file, it deletes only the file, the objects that are within the file. So basically, if I were to delete some kind of object from my file and then issue that thing, that command, it means that, for example, it can be left on my cluster. So take care about that. If you need to remove some kind of object, use tools like Argo CD or other things that works by tracking the object itself. But this is just a side note. You don't need to have know that for the exam. Okay, so I deleted all the things. As you can see, there are no such objects on the cluster. And then we can go to blue-green. And now there are more files here. Let's open all of them and quickly see what are inside there. I will answer the question within a minute. So basically, we've got a couple of files here. As you can see, we've got a file called deployment blue, and here we've got a definition of deployment, which ends with the word blue. As you can see, it's everywhere. This is just the same application, but you see that this is blue. So this is the first file. Let's go to deployment green. As you can see, this is very, very similar deployment, but it contains a word green. Maybe let's also put that version here as version 2. Then we have ingress. What is important here? Oh, sorry, I've got error here. Ingress points to the service, and now be very careful and watch out on the names of the service. As you can see, the service does not contain any kind of blue or green naming. Let's go to the service blue. We've got two similar definitions. Maybe let me show them side by side. On the left side, you've got service blue, and on the green side, you've got service green. And just take a look here at the name. We've got the same name of both sides. You see that there is the same name on the right and on the left. Why is that? Because using that two files, we want to overwrite the same object inside the Kubernetes. But what is the difference between these two files? It's all about the selector. So basically, in the blue version, we've got the selector that targets all the pods with the label app blue green sample blue, and on the right side we've got the similar one with the green. Maybe let me go quickly to the deployment so you can see the sample deployment here. So as you can see, our deployment creates a containers with blue at the end. Okay, let's see how to use it in the practice. So first, I need to deploy the things that are common for all versions. So basically, I need to deploy ingress as well as one of the service. I will start with deploying service blue and also deployment blue. So let's do kube control apply F and then deploy ingress first. Let's see if it works. Okay, now let's deploy service blue. And also go and deploy deployment blue. And now let's see what we have on our cluster. Okay, I'm guilty. I haven't tested that before. So the name needs to be blue like that. And then we've got also container name, which also needs to be blue. However, to be honest, it doesn't matter. Just let me quickly fix the same thing here by deleting that so we don't have things like that in the future. And then we deploy deployment blue. Okay, deployment blue was created. As you can see, we've got things like that here. But what is important in our case is a service. You can see we've got a blue-green sample here. And if I were to click on D, you will see in a minute that there will be some endpoints pointing to our pods just after they will be ready. So let's wait a couple of seconds. Let's wait until they are ready. Okay, they are ready. Now let's go to service, press D, and you can see that we've got two endpoints that are ready, and that service is pointing to these two endpoints. So basically, at the moment, our traffic is flowing to the blue version, and you can see that there is a blue version over there. Now let's assume that we want to deploy a V2 in the manner of blue-green deployment. So what we need to do, we just need to deploy a deployment green first. And by doing so, as you can see, we've got more pods created here. Two additional pods are being created right now. Let's wait that 20 seconds in order for them to be healthy. And during that, I will answer the question, what approach do you prefer to change links using private operator, update labels, service with pipelines? I'm generally a big fan of things like GitOps. So this is the first thing. I try to not modify any objects outside of the Git. So basically, for example, if I deploy a new version of container, what my pipelines do is basically they commit to the Git a new version of deployment, including that container name. There's actually, let me quickly find that, gitlab.com CI. If you are interested in things like that, I've got something for you. Just let me quickly find it. You go to my GitLab with that address. Let me paste that within the chat. You will see that there is a file called Argo CD deploy base, and what it does is actually this is a quite complicated script that does a couple of things, but the most important part here is it actually modifies the file inside the Git repository. So basically, I've got a Git repository with all my manifest, and after the new version of container is built, I edit the file within the repository and that commit them with the change of the new version of the image. So basically, then Argo CD, which is a continuous deployment tool, notices that the Git changed and then deploys all that changes. So actually, I try to do all the things like that. If I were to change the things like labels or versions or anything else, except the number of replicas, I do it through the code. And there is also a project called Argo Rollouts. This is a very, very nice tool. If you want to have that automated, you can use that specific project. Maybe let me quickly show some kind of example. Getting started, basic use. So basically, you can include some kind of strategy for deployment, and it can support blue-green deployments. It can support Canary and other things. I usually teach that on the on-site workshops if I have any kind of advanced workshop, and then I cover things like that because they're quite advanced. This is the one thing. And other thing that you can use in order to get things like Canary deployments is using service mesh like Istio. So this is it. Okay, let's go back to our main topic. We've got blue-green deployment here. As you can see, we've got simultaneously running two versions of application. However, as you can see, our ingress and our service still points to the blue one. And if we go to service, SVC, sorry, and go here to that service and describe it, you can see that we've got still got a previous version of pods. So actually, if I want to update that thing, and I now tested, let's assume that I tested my green deployment, and now I want to switch my application to that specific thing, I can do it by simply applying my version of manifest with service green. And what that apply does, it changes the selector for my service. As you can see, it changed. you can see that the current version of the selector is blue-green sample green. And you can see that also the IP endpoints changed for my applications. There are new IPs here pointing to the new pods in my application. And as you can see, my application instantly switched to the green version, and now all traffic is instantly flowing to the new version. So there are no multiple versions running from the point of view of the customer. Customer sees instant switch to the new version. So especially if your application requires something like that, then blue-green is a good practice. Okay, now let's go back to my presentation. Let me quickly describe a Canary deployment for you. I won't switch screen because I will be using that within a second. So basically, one important remark here. As you see, there are no magic objects natively supported by Kubernetes. So you cannot use blue-green deployment. There are no object that you just put that object inside Kubernetes and it does the work for you. You need to do it manually. However, as I mentioned, there are other projects like Argo rollouts, which can cover things like that. And then we've got a final topic related to deployment. What happens to Blue service? Okay, let me quickly show you that. Nothing happened because service was not named Blue. If we were to, I don't have color diff. Service, let's compare both services. As you can see, the only difference between the two files is actually the selector. So I'm not changing anything in that service. So basically what I do is I just override the same service object within the Kubernetes and I'm just changing the selector. So this is just it. So there were no blue service or green service. We've got only one service that is used over there. So just to show you on that screen, you see that there's only one service and we just switch the selector here. Okay, Canary deployment. So the history of Canary deployment is quite interesting because it was first used in mines. So miners were using canaries as well as other animals. These are called signaling animals, if I remember correctly. And what they did, they basically put that canary in some chamber in the mine and to check if there are some gases, for example, methane or other gases. I'm not really into mining. I only mined cryptocurrencies and there were no gases involved. So I don't know details. However, the idea is to put the canary in the chamber in the mine, and if the percent of gases in the air are too high for people, then canary dies, and that means that people should not go there without proper oxygen mask and other stuff. So this is just to say check if something is healthy. If canary is healthy, it means that chamber is okay. And basically we adapted that approach not to cryptocurrencies mining but to our deployment. So basically it's all about deploying new versions along the current one. So we've got two versions that are running simultaneously, but we redirect some percent of traffic to the new version. And why we do it? We do it to handle such cases like application lacking performance, that where for example, we've got a very big database on production. We cannot simulate that database properly, or maybe we cannot simulate some kind of integration with the service. For example, I created a product once that were integrating with Thomson Reuters newsfeed for macroeconomical data for financial markets. And basically we were able only to use one IP to connect to that service. So there were no ways to actually test that on other environments than production. So we did exactly what I'm saying. We did a canary deployments where some part of traffic were redirected to that new version in order to test on the production. So basically, we can say that customers are doing a test for us, especially when it comes to the performance, because sometimes it's quite hard to mock the actual production environment and test, for example, application performance. And using canary deployments, we can get actual traffic, actual volume of requests, work on actual data, but with newer version of application. And what else? It's kind of similar with rolling update, but there are two key differences. So by design, it's slower than rolling update. So rolling update tries to do it as fast as possible. If only health check is healthy, then Kubernetes proceeds and continues with rolling deployments to do it as fast as possible. On the other side, canary deployment can be slow. Canary deployment can not only take minutes, but for example, if you need it can take multiple days or even months to test new features or new capabilities of your application. And also the main difference between rolling update and canary deployment is that we control that canary deployments using some external tools. So for example, we can plug some kind of application performance metrics to that canary deployments, and canary only progresses if that performance metrics are met. And usually canary deployments are, rolling out slowly, so we don't want to put all traffic on the new version of application. Again, there are no magic objects to support that kind of deployment inside the Kubernetes. You can use Anchor rollouts, as I mentioned before. So actually, how can you get that kind of deployment in Kubernetes and maybe use that specific thing? Let me draw that first for you. So basically, it's kind of the same as we've got for our blue-green deployment. And I will use the same terminology and same colors. We've got a couple of pods in V1 and V2. V1, and then we've got a new version with V2. Maybe write only two of them. And now the main distinction here is that we've got a service that points to all versions simultaneously. So basically we've got the similar situation as we had in the rolling update. But what's the difference? The difference is because difference is in that we've got two deployments here. So basically we've got one deployment here, and then we've got second deployment over there. And by using two deployments, we have a complete control over how many replicas are running for the specific version. So I can set my, for example, green deployment to be only set to one replica, and on the other hand, I can set my blue deployment to be 9 replicas of blue pods, and this way 10% of traffic, as you can easily calculate, will go to the newer version of application. So this is the easiest way to simulate like that. So what can we do in order to change our blue-green deployment to canary deployment? Actually, it's quite simple, but let maybe quickly commit that so I won't overwrite my changes. And what we need to do is we simply just need to deploy, sorry, not deploy, but remove selectors here. So basically I need to change the label of my deployment. And I need to also, I need to put it like that. And we need to introduce, for example, so what I'm doing here, I'm adding one line for service. We will use that label to actually select all the pods. However, I need to still make some label used for the selector for the deployment. So I'm just duplicating here and adding another line here. It will be called SVC. Of course, you can name it as you want. And now we will copy our service blue, for example. And inside that canary, I just remove and adjust a selector here to point to SVC canary. Now let's apply that. And let's also deploy my both deployments. Sorry, too many files. Want to service canary and then deployment. In fish, it doesn't work like that. Expected green, and we've got blue. And what is happening right now on our cluster? So basically, we've got 4 pods, as you can see. Oh, there will be 4 pods within a minute. And then we've got our service that points, D. Actually, it will start to point to all our pods within a minute. So you will see that in a minute. Let's wait for a moment. And let's see if the labels are correct. Yes, the label is okay here. Let's see if our service, yeah, at the moment our service, as you can see, sees 2 endpoints, and probably within a minute or 2 it will see as well other pods. Yeah, as you can see, we've got 4 pods currently, and our service points to that specific pods, to all pods we've deployed as a part of that application. And now, if we want to decide or maybe set the number of or percentage of the traffic that should go to the green deployment, we can simply scale. For example, let's scale blue to 9, and then let's scale green to 1. And this way, we can forward 10% of the traffic to the green version of our service, which represents our new version of application. So yeah, this is something like that. Let's go to the pod, and you can also see that at the moment we've got multiple blue pods, and there will be a single green pod after Kubernetes converges with the deployments. So this is it. So this is how it works like for Canary deployment. As I mentioned, there are no magic objects for that. You can use that service mesh or Argo rollouts, and they natively support that kind of strategies, and you can use it for your own. But during the exam, of course, you are doing something I showed you just before. Okay, a final topic, which will be a quick one, because Helm is quite quick to learn in terms of using. However, there are many of corner cases in Helm. So we will cover the basics today, and maybe somewhere in the future we will cover all the details regarding the Helm. So what is Helm? It's a package manager for Kubernetes. So basically we've got package managers for every system. We've got Chocolately for Windows, for example. There's also some kind of PowerShell gallery for scripts and other stuff. And in Linux, we've got DNF for Fedora or apt for Ubuntu. And Helm makes a similar approach for Kubernetes. So basically we've got artifact, something that is called Artifact Hub. Let me quickly maybe open that. Artifact Hub IO. And here there are ready to go packages that you can use for your Kubernetes deployment. So for example, let's say I want to deploy my SQL on my cluster. And as you can see, there are multiple packages that I can use. The packages has different approaches to deployment of that databases. They are updated also more or less frequently. There are a couple of publishers that are verified. That means that many people are trusting them, and also this is some kind of company that Artifact Hub verified. I highly recommend Bitnami. Bitnami creates great Helm charts. They are easy to use and usually offer a lot of features. And when we go here to that specific chart, chart is something. I mean, in Helm terminology, chart is that kind of package. So we are not talking about the package, we are talking about chart. For Polish people that are here, the chart is translated as mapa in terms of navigation on the sea. It's not chart like the chart you are drawing, you know, some numbers. I mean, Wykres, it's like mapa, not the other one. So this is a chart in terms of sea navigation, and you are using that chart, you know, to quickly navigate and deploy your software. So this is it. And Helm is something that you are using to steer your ship. So actually, as you can see, everywhere here in Kubernetes world, there's something related to the sea and to the ships. Okay, back to this topic. Let's end with that side comments. We've got a couple of things here that may interest us. Of course, we should read the documentation because it can save us a lot of time. And what we can see here is there are parameters that we can set for our specific charts. As you see, there are hundreds of them, especially if the chart is quite popular or has all the features that Kubernetes provides and takes advantage of that features. But to simply use that chart, we can call install here, and it tells us what we need to do to install that chart. So basically, if I want to install MySQL on my cluster, I can just copy the first line. Let's go to Helm and paste that line. I probably already have added Bitnami. So as you can see, it's just skipping. And then I can go with the next line, which is Helm install MySQL. This is the name of the deployment we are providing. And then there is a localization of the chart. So basically, this is a repo / name of the chart inside that repo. One repo can contain multiple charts. I can copy that. And I can simply press and paste Helm install. Probably there is no such version. Let me quickly do it without the version specification. And as you can see, it's installing in our cluster. As you can see, there is a new pod that that specific chart created. It also created stateful sets, if I remember correctly. Yes, it created a stateful set for our MySQL. And as you can see, that service should be running within a minute on my cluster. It was as simple as that to deploy MySQL service in our cluster. It also deployed some kind of service here. So you can see that it's instantly available for other services running on the cluster. We just need to point to MySQL service, and then our services can just connect to that thing. Of course, if we need to expose that, I just recall that, I just recap that we can edit that file, that service file, and then we can change that to not to be a cluster IP, but the load balancer. But keep in mind that you can't change the name of the type of the service. We need to delete that and then create that again. Okay. And also there's one important remark here. Basically, if you are using Helm and then we are using that not only to install our software, but also through the whole life cycle of our chart, we probably want to update our software as well. So if we are using Helm, it will override our changes if we do them manually. However, there is a way to parameterize that and change the configuration of of my application. If you go here, you can see that we've got something called default values. And if I click here, you can see that there is a YAML file that provides a sample values, a default values for our chart to configure. So what I can do, I can overwrite that things and that parameters that are within that file, and this way I can change some of the settings of that specific deployment. So for example, let's go to auth and for example root password. As you can see, there is a parameter root password over there. If I want to set it up by default during the deployment, or maybe I want to update my application and set that specific thing, I can do the following thing. I can go to values and then type auth and then root password. Very secure. And by using that approach, I can call Helm update and then provide some kind of file with values. And this way, upgrade. Not update. And this way, as you can see, I'm introducing some kind of changes to our application. And you can see that there is a change like that here using the revision. You also see some basic information like version of the application, version of the chart, and also, which is very important, especially if you are new to the specific chart, it also outputs some kind of README, but this is not just a dummy README. This is a README that is dynamically generated, and it also contains so important things. As you can see, we've got ready to use commands, for example, for extracting the root password from the secret from our Kubernetes cluster, as well as we've got a sample command that runs a MySQL client inside the container and connects us to that container and also connects us to the database. So it's quite useful to read that README and see what authors wanted to do. So it's quite useful, yeah. Okay. As you can see, our application is updated. By the way, we can also go here and type colon and then Helm, and K9S can go to the Helm section where we can see that there is a chart called like that, and it's deployed, and we can also inspect that specific chart. As you can see, we see some of the basic information as well as that README. So if you for example, close your console but want to go back and see how to actually use that, you can use the thing like that. Yeah, so this is basically it. And by the way, by pressing Y, the key Y here on the Helm chart, you can inspect all the things that were generated by the specific configuration you provided to the Helm chart and by specific Helm chart. So as you can see, I can now inspect all the objects that were created here. So this is it. As you can see, it can create a lot of objects. So this is quite nice feature, quite useful to know that there is such a functionality here. And what else I want to show you? Now I want to show you how to uninstall that specific chart. So I can actually go over there and click uninstall. I need to remove the repo and chart name. I only need to specify the release name, which was MySQL, and as you can see, it was removed at the first stage. So basically, if I go to the cluster, you see that it was all deleted from my cluster. I see that there is some question. Just one final remark over Helm. So basically, if you are using Helm install, I strongly suggest that you also specify some kind of namespace. For example, MySQL. And then if the namespace is not existing, you can also put something like that. And this way, Helm will create all the objects except for the cluster-wide objects inside that specific namespace. So you've got a nice separation of different applications. And to be honest, I highly encourage you to deploy each and every application to the separate namespace, because it's just more cleaner and more easier to navigate. And also you can leverage all the things related to role-based access control to limit the users from using the specific namespaces. Yeah, and as you can see, it creates a new object inside the namespace called MySQL. Yeah, so I basically covered all the things I've got prepared on my chart. And before we go to the final things and answer your question, just to remind you, next week we are meeting and to talk about application observability and maintenance. So we will cover more things related to the health checks and also a couple of things related to the monitoring of things. Then we've got application environment configuration and finally services and monitoring. Okay, so it's now time for your questions. Do you have some useful tools, maybe graphical, for reading cloud resource definitions? Sometimes documentation is poor or not well prepared, and it is worth to go through CFD or even operator code. To be honest, I read them manually, but you can also import them to things like IntelliJ to have some kind of dynamic auto-completion. I'm not sure if Visual Studio Code supports that, but I remember that I saw somewhere in IntelliJ that it can support things like that. Are Helm charts are the part of the exam? I mean, the part of the exam is to actually cover that kind of. Go over there. So you need to know how to use the Helm package manager to deploy existing packages. I'm not sure if you were actually to deploy and find anything on the internet. I suppose not, because you are only allowed to go to the Kubernetes documentation, not to the artifact hub. So it may be quite hard to determine which values should be deployed. However, I can imagine that there is some, predefined values file, and then you've got provided some kind of URL for the repository, and you need to do some kind of basic flow with just deploying that things using Helm. So I think, I to be honest, I don't expect tasks like that, to find and use any kind of more advanced Helm chart. And just to remind, creation of the Helm charts is not part of the exam, so it's quite good, because it takes a lot of time to create a good Helm chart. If you don't have any question, we'll be coming to the end. Just one more trick. There is also, if you don't want to install some kind of Helm chart, you can do something like that. You can call Helm template and then provide name of the release as well as repository, and it will output all the things that it will generate and apply to the cluster, as you can see, and then you can inspect that before you deploy that actual things to the cluster. So this is quite a useful trick at the end. Okay, so thank you for being with me today. If you have any questions, you can go over there. Don't forget to give me a thumbs up. Also, I will be very glad if you can share that study group on your social media. I usually post that on LinkedIn as well as on a couple of groups about Kubernetes. But if you like the idea, you can share the specific link, or maybe a link to the sign up page for the whole series. So I will be very glad, because it helps me reaching more people and helping more people. So thank you for today. We've got one more question. Are you able to propose some useful tools for linting YAML? Basically, you can just put it in YQ. I don't remember if there is a tool called YQ. YQ, and this is very nice. This is similar for JQ tool. However, it is used for YAML, and you can not only show it in the nice formatted manner, but also you can query it using similar to JSON path. I mean, this is actually JSON path because YAML is a part of subset of the JSON. So actually, and this is a JSON path, and you can use it not only for reading, but you can also use it for editing the YAML file. For example, as you saw before, and you can see in my pipeline, which I pasted to the chat, I'm using YQ to actually overwrite the version of the image inside the deployment. So this is quite useful tool, especially if you need to, alter YAML files in so automatic manner. YQ is one thing, and also I highly recommend you IntelliJ. I've recently, to be honest, switched from Visual Studio to IntelliJ because IntelliJ has a really great support for Kubernetes. Maybe I will record a separate video about that, but it's really good. And as I mentioned before, you can also point it to additional schemas like CRDs, so you've got that kind of auto completion. Okay, so thank you for today. I think I cannot talk anymore today, so I will just want to say goodbye to you and see you next week. Bye bye.